Okay. So I'm gonna, for those 2.3, 7 equations, gonna do a bunch of them. Okay, that's what you missed. So let's add, yeah. No. That's at the phone for some reason. Add 7 to both sides, right? Leaves us with x divided by 3 equals what? 5. And now what do we do to both sides? Because that undoes dividing by 3. And what do we get? Oh, wait, why did I put 5 there? Okay, we'll get there. 3. And these cancel, right? Equals 15. Does anyone not understand how to do that? Did it confuse anybody there at all? You got that part or no? Okay. So what are you going to do first to solve this one in B? Okay? And then after you subtract 3, what are you going to do? Well, we want to undo multiplying by what? What undoes multiplying? By 4. Right? Yeah. All right, so everyone, go through, try B, let's see what we got. Hold on. We talked about it. What are you going to do first? Yep, well, mine is not a verb. We're going to subtract 3 from both sides. Exactly right. There you go. Yeah. So that 3 is gone. You should have equals, right? Okay, go and erase that. 3 minus 3 is 0, right? So nothing else before x. What equals? An equal sign. Oh, get rid of that. What is negative 17 minus 3? The number line. The 0 is on the number line here. You go negative 17 this way. You do 3 more. That's what we have. Negative 20. Right there. Now what are you going to do to both sides of 50x by itself? No, hang on. No. Right. Try to do math and pencil. It's currently being multiplied by 4. How do you want to do multiplying by 4?
This is easy.
Divide by
Actually, I'm going to just do that.
No, right, come on. You see how I do it? Over 4. On the other side, over 4. So what do you have here? Equals negative 20 divided by 4.
Mr. Hefner?
Yeah.
If I get my homework in due by lunch, can I?
Yes.
Or not by lunch, by get lunch.
Yes.
My next period.
What do you got?
Because I only have
Let's see. Subtract 3. Why you multiply? So you divided this by 4. Whatever you do to this side of the equal sign, you do the same to the other. Right? Remember, the equal sign is like a balance beam, isn't it? If you add and subtract weight from it, you have to do the same on the other side. Keep it in balance. With this one? Oh, stand by. What did you get for this one? Almost. Negative 20 divided by 4. It's not 5. What is it? Negative 20. Negative 20 divided by 4 is not 5. It's not positive. Negative 5. Right? Now we got negative 5. Yeah. Well, I'm not on D yet.
Oh.
I'm on B right now.
Oh.
So there you got 4x equals negative 20. Divide both sides by 4. X equals negative 5. All right? And part C looks like it's going to act the same way. I mean, I guess if you need a calculator for now, everyone just move through these right now. Just go right through them, okay? Wait for me. What you said, G? Why don't we, okay, hold up on the fraction ones for a minute. So guys, when you get to F, just stop for a minute. I can get you squared away on your fractions. B. Multiplied by 3. Good to me. Bracket 7. What's wrong with that? Circle. Yeah, that looks good. Dan, did you get C yet? What was the first thing you did? Tell me, I can't see. Go back to 12, and then what did you do? Divided both sides by 5, yep. Yep. Come on. Here. All right. Oh, I'm recording. I should have paused it, but whatever. Let's try this here. Minus 12, right? So we got 5x equals 75, right? And hopefully you didn't need a calculator for that to get 15. Okay? Negative 1. Yep, so this one here, I want to undo dividing by 3. Can multiply both sides by 3, right? Because they'll cancel. And then what now? Subtract 7 from both sides, and I got x equals negative 1. All right? How about for E?
Oh, that was the one I had trouble with. But I got
There's
negative
2 ways to do it. You can distribute, or you can just divide the 6 out of it.
I got negative 2.
Negative 2.
Okay.
So, I mean, you could distribute, that gets a little messier, and it just seems easier here just to undo that multiplying by 6, by negative 6, by dividing both sides by negative 6, right? So they cancel.
But that's negative 3, isn't it?
Huh? Or what? No. 8 divided by negative 6 is negative 3, yep. And then what?
Add 1.
Is that under subtracting 1 equals negative 2. Okay? If you distributed, probably a couple more things there to do. How about for F? What did we get? Lowest terms fraction.
Negative 1/2.
How many got negative 1/2?
I got 1/2 out of there.
Well, we better look at it then. We got it. How do we undo adding 2? From both sides. 8x equals negative 4. Undo multiplying by dividing both sides by 8. So I don't know how you get positive.
Yeah.
It's a negative. So negative 4/8 in lowest terms is what? Divide that by 4 and that by 4, negative 1/2. Okay? Okay. But down here, there's a couple ways to handle these fractions. I know you guys hate fractions. No?
I actually, yeah, I do.
Remember with a fraction, guys, whatever's in the top means you do what? The top part of a fraction means what operation? Multiplying, in this case, by 3. And the bottom part means to divide, in this case, by 4. Well, let's get it cleaned up first, right? Let's get rid of this negative 5. Do what? So we have 3/4 x equals 9. So 2 things are being done to the x, right? What are the 2 things that's being done to it, everybody?
Divide by 3.
Can it multiply by 3 and divided by 4, in either order, it doesn't matter. So we can handle the dividing by 4 by doing what to both sides? Multiplying by 4. Now hang on, don't write it down yet. I'm going to show you a shortcut here. And we can handle multiplying by 3 by doing what to both sides? Divide by 3. Why don't we just do both of those things at one time? Hey, Ken, watch. Multiply by the reciprocal. You know what a reciprocal is?
Yeah.
Just flip the fraction, right? You guys with me on that? Instead of doing 2 separate steps there, I'm just doing it in one. Multiply by, I just flip it and multiply.
What's that?
So the 4s are top and bottom, they're going to cancel, right? 3s are going to cancel. What am I left with? X equals, okay. What is 9 divided by 3?
3.
Times 4? 12. Well, let's try it the other way. What is 9 times 4? 36 divided by 3 is 12. Get the idea? Okay. So one of you guys try it now with H, kind of similar. Clean it up first, the 6, right? And after that, what are you going to multiply both sides by after you clean the 6 out of there? Negative 2 over 5. Keep it negative, that's already nice. Negative, flip it, both sides. Get the
So
idea?
you multiply by 4 and then
What?
divide.
Oh, here. Yeah, she's back here. And then divide by, or the other way.
Okay.
You can divide by 3 and then multiply. Came out the same. Subtract the 6 out. So we have negative 5 halves x equals negative 5. So I want to undo multiplying by 5, and also I want to undo dividing by 5. So I multiply by the reciprocal of this thing, but I want to keep it negative, right? So negative 2/5 on both sides. With me?
Yeah.
So now here, see the, of course, the negative times a negative, that is a positive, right? 2's cancel, 5's cancel. I'm left with what here? X equals, negative times a negative is, okay, what's 5 times 2? Divided by 5. Okay, try it this way. What's 5 divided by 5? Times 2. Either way. Okay. Oh, last one there. Why would they even bother putting that one there?
So it gives you a little break.
I guess, yeah.
Unnecessary.
No decimal answers. It's going to be a lowest terms fraction answer. Anybody get I yet?
No, I'm trying to. Yeah.
Put in the lowest terms fraction. Just make it lowest terms.
2/3. Negative 2/3.
Yeah. Like if they don't divide out to a whole number, just leave it as a fraction in lowest terms, right? So hopefully you got this part. Subtracted 3 from both sides. 6x equals negative 4. Then you divide both sides by 6. Okay. Yeah, obviously it's not going to come out to a nice whole number, right? So just get it in lowest terms. Divide top and bottom by what? 2. 4 divided by 2 is 2. 6 divided by 2 is 3. Negative 2, right? Okay? What do they do with you guys in fractions in grade school, middle school?
Not really anything.
Yeah, they don't really get like
Okay. All right, let's look at exercise 2. Solve the following equation for x by identifying the operations that have been done to x. So it's just like yesterday, right? Let's just go through the thing and saying what gets done to the x here first, okay? So PEMDAS, right? And like remember, if you were to plug some number in for x and do all this stuff to it, what would you do first? Good stuff in print, right? So subtract 3.
Multiply by 5.
I should be, might be a little more room here. I don't know. So subtract 3 3, and that result gets multiplied by 5, right? Divide by 5, and then what? Divide by 8 after you do that? And then the last thing you do is add 2. Okay? Now, just like yesterday, if you were going to go solve this, we do the reverse of all this, right? So we start down here, and what's the opposite of adding 2? Everybody, subtract it. Now, everybody, what's the opposite of dividing by 8? Everybody. Multiplying by 8. What's the opposite of multiplying by 5? And the opposite of subtracting 3. So we're going to start here and do the opposite of that, working this way. So let me, let's just write down this thing. So 5 times x minus 3 over 8 plus 2 equals 7. All right? So, let's start out by doing what? Yeah, clean this up by subtracting the 2 from both sides, right? This is a balance beam. So we have 5 times x minus 3 over 8 equals 5. Now what?
I can see multiply by 8.
Yep, both sides. They cancel. 40. And now what?
Divide by 5.
Divide both sides by
Okay.
5. Sorry, I'm getting a little sloppy because I'm trying to reach. Leaves us with x minus 3 equals what? 8. And finally what?
Add 3. Nice and smart pieces.
Yeah, x equals 11. All right. Well, maybe a little better about this now? Okay. Let's move on to this next one here. Got it?
I don't have the up there. I don't have the.
Okay, well, we'll come back to it in a minute. All right, so now we have this equation. 5 times x plus 3 plus 2x equals 4 times x plus 3. By using the district, now, notice here, we kind of have to use the distributive property here first, right? Everybody see kind of why? Because we have an x term that's outside of that, right? And we need to get like this x term out of here and combine it with it. Does that make sense?
Yeah.
So this will be one where we really, I told you that it kind of varies from problem to problem. We'll have to distribute here. All right? So by using this, we're going to rewrite the expression. So let's just go ahead and do that, right? Let's distribute the 5 through here. What do we get, everybody?
5x minus 15
Plus 2x equals, and now let's do the 4. Plus 12. And also, we have x's on both sides, right? You guys know what to do about that, yeah? We need them all on one side, don't we? Well, let's get our like terms combined over here. 7x minus 15 equals, was plus 12, right? Yeah. Okay? So that's the new equation. That's just, they wanted this to write this in a cleaned up way, right? So now we're in part B, they want us to solve it. It's kind of weird. I'd like to just do it here, but anyway, we'll just take it over here and solve it, right? So we got 7x minus 15 equaling 4x plus 12. Okay, so I want all my x's on one side. Of course, you know, it really doesn't matter left or right. I got a thing about, I like to have my x's all on the left side. I don't care if it ends up being a negative, it doesn't matter, right? I want it on the left side. I'm not gonna make you do that if it feels better, whatever. Okay, so I want to get this 4x over here to this side. How do I do that? And if you tell me just move it over, no. What do you got to do? What? It's positive 4x, right? So to get it from this side, I subtract it from both sides, and that'll get it over here. So minus 4x there, I'm lining it up under the 7, so what do we get? Now it looks like any other one, right? What do we do now? So we get 3x equals what?
27.
27. And now what?
Divide by the 3.
Divide both sides by 3. 9. Okay? You have x's on both sides. You want to get them all on one side. Okay?
I used to use the line, but now it's better not to use the line.
Oh, like this for you draw. Yeah, try and stop doing. I just like
I tried
Boss
to do
was
it.
letting her students do that.
letting them.
Like
She
having
actually
them do
used
that.
it. Brooke Elson said that she, like, or she uses it.
Yeah, actually.
Yeah,
I know
you
it
have to
was
do
a
distributive property with it.
Either way, she said that Miss Foster would.
She won't for long. She won't for long. I'm trying to get you guys to be big kids a little bit here, right? You don't need to look like. Okay? All right. Let's look at this next one here. We got, so you see we have to kind of distribute here? Because we have x's all over, right? And we need to get them all together and combine. So in this case, again, we have to distribute, okay? So let's get this distributed, combined like terms, cleaned up, right? And then it'll look like a simple equation to solve, right? So let's distribute the 7, and then distribute what over here? The 3? No.
The negative.
The negative 3, and then distribute the 5. Go ahead, distribute that 7. What do we got? Minus 14.
Minus 3x minus 9.
Minus 3x minus 9 equals
5x minus 15 plus x.
15, and then just plus x.
But we could add the x, so it's.
So now, yeah, let's combine like terms before we start moving on the side of the equal sign, right? Get it cleaned up. I know a lot of kids will start trying to get stuff on each side of the equal, so get it cleaned up first, combine like terms. So that's 4x, negative 14 minus 9 is what?
On the other side, it's 5x.
Hold on, whatever. I meant that second. Hang on. Okay. Negative 14 minus 9 is?
That's what's 23.
Keegan, what do we have over here?
It's 6x minus 15.
Okay. So
I
you
was
guys,
talking about that side. I didn't mean to say 5x times 6.
oh, okay.
Because I usually get the 5 plus 3 is 7. I don't know why. It's just always been like that for me.
Yeah, fix that.
Yeah, I know. I always mess it up.
Okay, so you guys take a minute and work this through now, because now it looks like this one here, all right? So everyone right now, get your x's all on one side. I like them on the left. I don't care if it ends up being negative. I like it on the left. Don't let that bother you. So maybe some of you started out by getting this 6x over here by subtracting, because it's positive. You got to subtract it to get it out of there, right? Or you probably then, I don't want it negative, so you subtract the 4x, whatever. Negative 2x minus 23 equals negative 15. Did you do it differently than I just did there, Hannah? No. Okay. Because again, like I said, some of you, maybe you subtracted 4x from both sides. You got all your x's over here. Or did you start out by adding 23 to both sides? That works. You can do that too. Yeah. I usually just start with the x's and get them all. But yeah, you can add 23 to both sides to start that. Then you still got to get the x's. Good.
Got my lunch.
So you're probably fine. Just keep going.
I don't realize how much I use my watch until I don't bring it.
Good.
No, for like the time. But you said that pop because
You have a screen
Close,
that
close.
says 1023, has time on it.
Yeah, that's close enough.
I get it. We have like.
Not like you're watching a space show, you'd be down with the
Have a
panel.
couple Regents questions.
Well, I need to, if you think you want, yeah, but we'll see what you can. Everybody got something here?
Yeah.
Yeah, I have.
Did you get -4?
Yeah.
Okay then. So what I'm gonna do next is what? Add 23, right? Which is, I think, what you started with, Hannah? That's fine, you could, I saw someone else, you were start.
I started with that.
He did, yeah, either, that's fine, it works too, in this case. So -2x equals what? Positive 8, divided by -2, x equals -4. All right? Okay. So let me ask you a question. Some of you guys are a little hesitant out there. Is there, right now, I want to know, just raise me, if there's somewhere in here, you got lost or turned around. Yeah, where? Right, yeah, that's what I was trying to say is, I saw some of you guys, you started out by adding the 23 to both sides, and this, you can do that, right? I just led with getting this over here. Eventually, you're gonna, I mean, they both have to get done. In this case, it doesn't matter which one gets done first, right? So don't worry about that. Now, here's what I did what you did first, right? Okay, so you with me there? Was that the only thing that, okay. All right, we'll go on to part B then. And we're gonna hit a couple Regents questions here. So hopefully you got this part. You got 9 minus 6x minus 6 equals 2x minus 8 plus 27. Is there something I should do here before I start trying to move things to either side of the equal sign? Would you do that? Would you combine like terms first? I would, right? Otherwise you get lost in the mess. So here we got what, -6x, right? And 9 minus 6 is what? Positive 3 equals 2x. It's 27 minus 8. Plus 19. Yeah? Keep going. Don't wait for me. Is that what you're saying? What? I thought you said you got confused. Oh, that's a -6x. That's going to change everything down here, right? Yes. Right, the negative stays with it. So you got to change that, and that's going to change that, everything else. That's why we do math and pencil. And careful guys, that negative stays with the -6x. Well, now it's just like all these like these simpler ones, right? Like that, right? Reverse order of operations, take care of that, and then take care of that. Raise your hand and give an answer. All right, good. We're looking. Yeah, because it's over here where it is, it's positive 2x. To get rid of it, you subtract it. If it was negative 2x, you'd add it, right? Yeah, you're doing it right. Yep. Precisely. Yes, ma'am. Yeah, that's, yeah.
So the answer is 2x squared, right?
Oh, no, you can't, that's, these aren't like terms.
So
You can't, you have to put on the line. Yeah.
yeah.
Yes. Yep. Yeah, when you do the add and subtract on both sides, you gotta line up like terms that throw any. Yeah.
I don't know.
Yeah, so what'd you get here? What's this thing?
What'd you get? None yet.
I don't know. Yeah,
Are you laughing at me?
She lost it everywhere.
yeah.
Who's she?
Oh, let's see here.
That was you.
Oh, okay. Looks good. So you get -6 minus 2. This is your number line. Number line, right? Here's 0,
Huh?
negative is here, so -6 minus 2 more, which you where? And that'll change the stuff below it too.
Do you
All right.
want to be recording this?
Oh, I should have paused it. So that's gonna be inconvenient to watch, I guess.
You should probably get that out of there.
What, so I gotta go edit the video?
This is gonna be like that.
Yeah, do you want to be YouTube?
Okay, quiet down. So I'm gonna start out by subtracting 2x from both sides, get all my x's over here. This is -8x, right? Plus 3 equals 19. Now I'm gonna subtract this 3, I'm trying to get the x by itself. -8x equals 16.
Divide by -8.
So that's, yeah, can't be pi, right? -2. All right?
This class is kind of easy.
Yeah, we'll see.
A little bit. I was falling asleep.
Okay, let's take a look at some Regents questions here. I'm going to show you some tricks with fractions. I know you hate them, but I can show you how to get fractions completely out of an equation so you can solve it just like these, okay? Because I know you don't like them. Oh, that looks like a mess there, doesn't it?
No.
No?
Uh-huh.
X minus 0/4 plus 2/3 equals 17/12. So, okay, let me just say, like, in a normal equation, you're going to want to subtract 2/3 from both sides, right? Which means that, like, to subtract 2/3 from 17/12, you're going to need a common denominator. Remember doing that?
Yeah, and you have to, so you have to.
That's one way. That's the messy way, right? And I really would prefer if you did know how to do it that way. But let me show you something that'll make all the fractions completely go away. All right, so pay close attention to this because it's a really handy trick. 'Cause I know you hate fractions. Let me just ask you, if you were going to get a common denominator here, like to add or subtract these, what would it be? Like what do 3 and 12 both go into? 12 doesn't go into 4.
24.
Or just 12. Doesn't 3 go into 12?
Yeah.
And doesn't 4 also go into 12? Okay. Yeah, well, yeah, but I'm worried about the bottom numbers.
You could just
That's true,
multiply
but
it
I'm worried
by-
about the bottom because I want them to go away.
Yeah, but multiply the 4 by 3/3 and the 3, the one with the 3, the 2/3 by 4/4.
Okay. That sounds great, but you're overcooking your grits. Hang on. Let me write this down. Minus 3/4 plus 2/3. You do the same thing I'm doing. Okay. So you told me that all of these denominators go into 12, right?
Yeah.
Okay. Let me ask you a question. If I was to multiply 17/12 times 12, what would be left?
17/12 minus 12.
Times 12.
1. Or
17. No more fraction, right? But these go into 12 as well, don't they? Okay. Watch what I do. Watch carefully.
I'm never gonna do it.
Okay. Let's do this. Now, 12 divided by 4 is what, guys? So I have here 3 times x minus 3. You with me?
Yeah.
Okay. What is 12 divided by 3?
4.
Times 2.
8.
Right? Remember, the bottom is divide, the top is multiply. Let me start with this one again. 12 divided by 4 is 3 times x minus 3. Well, for the moment, it's 3 times x minus 3. 12 divided by 3, is 4, times 2 is 8, right? And you gotta do every single term. Well, 12 divided by 12 is 1, times 17 is 17. Now you have an equivalent equation with no fractions. How many kind of understand that? So like whatever's on the denominator of the fractions, multiply by something that'll make it all go away. Now sometimes, if they're not all 12, you got something left there, like the 3 in this case, right? And the 4 in that case. Okay? All right, so now go ahead and solve that. You can either use the distributive property or, you got to subtract the 8 out of there, of course, right? Hold on. Got to give the rest of the primates a chance here. Work through it. Yeah.
I have the answer.
Okay. Again, primates a chance.
Oh, don't forget to record.
Oh, thank you. Thank you. So those watching this excruciatingly long video, you missed this part. I'm not going back. Anyway,
Something equals 6.
so choice 2. Okay? Let's move on to number 2 here. There's a couple ways to do number 2. So number 2, you could kind of try it the way I showed you up here. But since, look at the difference. This one up here had like these 3 terms, right? So it didn't really have available like this other method down here. Does anybody see down here something? I know you've done it.
Multiply that by 5 over 5. What? I don't know what that is. X.
You cross multiply.
4 times 15 and then
Yeah.
3 times.
Or why don't you try it the way I just showed you up here?
Mine's
Let me
just the way I know.
rewrite it down here. Shh. So let's try it the way, and I'll show you the other way. Now, I know you hate fractions, I know you hate fractions, but maybe you notice that 3 does go into 15 here, right? Hannah, can I multiply both of these things by some number to make the fraction go away?
Probably.
Okay, probably what number could I multiply by?
3 goes into 15.
Yeah, so what could I multiply both sides by? Okay. So if I multiply this side by 3, yeah, that'll go away. But if I multiply this side by 3, that doesn't go away. So
15.
I need to multiply it maybe with the bigger of the two. So, yeah, 15. Right? Look here. What's 15 divided by 3?
5,
Times 4. 20. And what is 15 divided by 15? 1. And then just x plus 10. Look at that x. Stupid. They're going to make me put the x on the right-hand side.
Just do x plus 10 equals 20.
I could.
Wait, you didn't have to put
Well, yeah, okay, 1 times that. I could, yeah. I mean, it's good, but technically, well, what's 1 times n? Doesn't change anything. So that's why, yeah. If it was anything other than 1, I definitely would put it in there. That's a good catch because by the letter of the algebraic law, it should be there, but it doesn't affect anything. Or Mr. Hefner's law.
I don't know how to do this, but I look at the team.
This is not what you do.
X equals 10.
All right. I can't write 10 equals, I can't. It's just so stupid.
That's what I did. It bothers me too.
Let me just show you the other way. When you guys have like fraction equaling fraction, how many did stuff by cross multiplying?
Sheesh.
You heard of cross multiplying?
Yeah.
Okay, just watch here.
I heard of it. I heard it.
So, like cross multiply means to kind of multiply diagonally, cross. So 3 times that mess, and then 4 times 15. Watch carefully though. 3 times this entire thing. So this would be 3 times parentheses x plus 10 equals, what is 4 times 15?
16.
60. That's now can you solve that? You ever cross multiply? You just did. Did you do that? So the answer is yes, you cross multiply. Okay. But I guess not before you got here? Or you don't know, you were asleep that day. Okay. Well, at least you're staying awake.
I got him to sleep in this class, so I had a.
You want to distribute or just divide by 3? I want to divide by 3 just for spite. Anybody get this? Oh no, we already did it. It should come out to 10. That was a stupid thing. So we got x plus 10 equals 20. X equals 10. See, same. Cross multiply. Either way. Okay? Now, if you see a problem like this, I don't need you to do both ways. I'm just showing you. Okay? One or the other, unless the directions say specific. Why are you so happy?
Why do you look so scared of her?
Well, give me the evil,
Mr. Barron's scared of her too.
give me the stink eye, or it may be the evil.
The evil eye.
Okay. All right, let's take a look. Oh, by the way, this one should not be in this section. This is one we're gonna cross out for now, but when we get all the way out to like 2.13, we got to come back and do it. So just cross that out.
13.
Yeah, it's part of the editing process. It got thrown in here for some reason.
More questions. Oh my God.
Flip the page. We got more.
Only 5 minutes?
Well, I'll tell you what. Let's stop here and we'll finish these notes tomorrow. But you have enough. You can do the problem set.
Is
Okay.
this, yeah, okay.
So you have 2.3 problem set due for homework tomorrow. Okay.
Just